Welcome to Claude Food Delivery. I'm your host, and today we're diving deep into a fascinating technical project, building an AI-powered food delivery system using Claude, MCP servers, and modern APIs. We're talking about creating a conversational interface that lets you order food just by chatting with AI.
This sounds incredible. So instead of clicking through endless menus on apps, I could just tell Claude, I want some Italian food, and it handles everything?
Exactly. The system architecture is pretty elegant. Claude acts as your conversational interface, but behind the scenes there's an MCP server, that's Model Context Protocol, acting as middleware. This server connects to the Uber Eats API for restaurant data and PayPal for payments, with PostgreSQL handling persistence and Redis for caching.
MCP server as middleware. That's interesting. Why not have Claude talk directly to these APIs?
Great question. The MCP server acts as a smart gateway. It handles connection pooling, up to 50 concurrent connections, manages session state across your conversation, and ensures everything stays under 500 milliseconds latency. Plus, it provides a clean abstraction layer for Claude to work with.
That latency requirement is impressive. What about the actual ordering flow?
The user experience is designed to feel natural. You start with restaurant browsing. The system can return up to 1,000 restaurants based on your location and preferences. Menu data is cached for 5 minutes to keep things snappy. The documentation specifies some really thoughtful API endpoints here.
Let me guess, there's a Get Restaurants endpoint?
Spot on. Gesh Restaurants takes latitude, longitude, optional radius up to 50 kilometers, and cuisine filters. It returns restaurant data with ratings, delivery times, and fees. Then there's Get Restaurants/ID/menu for diving into specific menus with category filtering and availability flags.
And when you're ready to order?
Post Orders creates the order with full validation, restaurant ID, items with quantities and customizations, delivery address with coordinates, and contact info. The system uses idempotency keys to prevent duplicate orders, which is crucial for payment processing.
Speaking of payments, how does the PayPal integration work?
The Post Payments endpoint handles this beautifully. It takes the order ID, amount, and payment method details. The system supports both PayPal and credit cards, with full PCI DSS Level 1 compliance. Everything uses proper tokenization and encryption, AES 256 for data at rest, TLS 1.2 Plus for transmission.
Security seems to be a major focus. What about rate limiting and other protections?
They've thought this through extensively. Rate limiting at 100 requests per minute per user, 10,000 per IP. There's a comprehensive threat model covering SQL injection, MITM attacks, DDoS protection, and session hijacking. They even specify monitoring rules, like alerting when there are more than 5 failed payment attempts per minute.
That's thorough. What happens when things go wrong, though?
The error handling is really well designed. For API failures, there's exponential backoff with jitter, circuit breaker patterns, and graceful degradation using cached data. Payment failures get automatic retries at 5 seconds, 30 seconds, and 2 minutes. The system even handles business logic exceptions, like restaurants being closed or items out of stock.
I love that they specify exact error codes and responses. Like when a restaurant is closed, you get a 422 with the reopen time and suggestions for nearby open places.
Right. And the data models are incredibly detailed. The restaurant model includes everything from cuisine types and ratings to operating hours and delivery zones. Menu items have nutrition info, allergen data, and complex customization options. Orders track the full life cycle, from creation to delivery.
What about the conversational AI aspect? How does Claude maintain context across the ordering process?
The system preserves conversation context for up to 20 messages, handles clarification requests when confidence is below 60%, and even includes a recommendation engine using collaborative filtering. It can modify orders within 5 minutes of placement and provides real-time tracking updates via webhooks.
This documentation is remarkably comprehensive. From a technical standpoint, what stands out to you?
The attention to operational details is impressive. Specific timeout values, connection pool sizes, cache durations, even accuracy requirements like delivery time estimates within plus or minus 10 minutes. The authentication uses OAuth 2.0 with JBT tokens, API key rotation every 90 days, and proper GDPR compliance with 30-day data deletion.
Any areas where you think the system could be improved or expanded?
While the documentation is excellent, I'd love to see more about machine learning aspects, how the recommendation engine learns from user behavior, or how natural language understanding improves over time. Also, integration with other delivery platforms beyond Uber Eats could provide more options for users.
That's a great point. This feels like a solid foundation that could scale horizontally. What's your overall take on this as a technical project?
This represents a really thoughtful approach to conversational AI in e-commerce. The MCP server architecture provides clean separation of concerns, the security model is enterprise-grade, and the error handling shows real-world operational experience. It's the kind of system that could genuinely improve user experience while maintaining reliability and security.
Absolutely fascinating. Thanks for walking us through Claude Food Delivery. For our listeners who want to dive deeper, this documentation provides an excellent blueprint for building AI-powered ordering systems.
Thanks for the great questions. Until next time, keep building amazing AI experiences. Welcome back to Tech Architecture Deep Dive. I'm your host, and today we're exploring the architecture behind Nix, a fascinating system that bridges the gap between documentation and code. Let me walk you through how this thing is built.
Sounds intriguing. So Nix is dealing with both documentation and code analysis? That seems like it could get complex pretty quickly.
Exactly. And that's why the architecture is so interesting. They've gone with a monorepo approach, which keeps everything organized in one place. The system has three main packages. There's the API built with Fastify and PostgreSQL, a React frontend using Vite, and then a shared package for types and utilities.
I love that shared package concept. That must really help with type safety across the stack. But tell me more about this Fastify choice. That's not something you hear about as much as Express.
Great observation. Fastify is gaining traction because it's incredibly fast and has built-in TypeScript support. Now here's where it gets really cool. Let me walk you through the data flow. When a user edits a document in the web editor, those changes get saved to PostgreSQL through the API. But then something magical happens.
Ooh, magical how? Are we talking AI integration here?
Bingo! The AI jumps in and analyzes the spec quality right when you save. But that's not all. They've also got GitHub webhooks listening for code changes. And here's the kicker. The system does drift detection by comparing the spec against the actual code.
Wow, that's brilliant. So it's essentially keeping your documentation honest by checking if it matches what's actually in the code base. That could solve so many problems with outdated docs. What about the deployment strategy?
They've kept it clean and modern. Front end goes to Vercel, back end to Railway, and they're using Neon PostgreSQL for the database. It's a nice distributed approach that leverages each platform's strengths.
That's a solid modern stack. Railway for the back end is interesting. They're really making waves in the deployment space, and Neon for PostgreSQL gives you that serverless database experience. This whole architecture seems really well thought out for a documentation-focused tool with AI capabilities.
Absolutely. What I find most impressive is how they've created this feedback loop between documentation, AI analysis, and actual code. It's not just storing docs, it's actively helping maintain quality and consistency across your entire development workflow.
That's the kind of tooling that could really change how teams approach documentation. Thanks for breaking down the Nix architecture. It's given me some great ideas for our listeners who are dealing with similar challenges.